Welcome back to Stay Sharp in Digital Engineering, your key to unlocking success in the digital evolution of products and manufacturing. Get the full download on MBSE and digital twins when Jonathan Scott and I talk with David Long, a renowned MBSE expert and longtime leader in INCOSE, an association for systems engineering professionals. We explore how MBSE drives digital twin creation, we tackle adoption challenges, and what it means to unify architectures for success. Let's jump in. Welcome back, everybody, to Stay Sharp in Digital Engineering, your podcast about all things digital related to products and from engineering to manufacturing, service, and more. I'm one of your hosts, Julianne Grant, and today I am joined by my co-host, Jonathan Scott.
Hello, everybody.
Hey, Jonathan. It's always good to be back in the seat.
Always fun to talk.
It is. So today we are continuing our digital twin series. We've been talking about many of the components of digital twins over the last several episodes. So be sure to look back and see the different topics we've covered. But today we have a special guest with us to talk about MBSE, or model-based systems engineering, and how that fits into the digital twin concept. And so I'm really pleased to introduce David Long. Welcome, David, to the podcast.
Thank you.
We're really glad you're here with us today. So I met David at the Aris ACE 2025 event, where he was part of a main stage panel that talked about digital transformation, and he was very knowledgeable about MBSE. So David has spent more than 30 years helping organizations assess, adopt, and deploy methods to help their systems engineering proficiency while working to advance the state of the art. So David has been involved with MBSE for many years. He founded and led Vitech, where he developed innovative industry-leading methods and software to engineer next-generation systems. He also co-authored a primer for model-based systems engineering and delivers a lot of keynotes and workshops around the world, which is where I met him. And so the other thing I just want to mention, that David is an INCOSE fellow and an expert systems engineering professional. So David was the 2014-2015 president of INCOSE and currently serves as INCOSE's director for strategic integration as a coach and as a coach for INCOSE's Technical Leadership Institute. So that's quite the background, David.
It is. Oh, we're so glad to have you.
It's not your first day here. It is not your first day.
Okay. Yeah, looking forward to the dialogue.
Yeah. So with that, I'm going to jump right in then.
Please do.
And so to talk about MBSE in the digital twin, I think it's only fair that we define what we mean by MBSE as we get started. And so I'm gonna take my rudimentary view of this, right? So I got some formal training in systems engineering in MBSE, but I consider myself a novice by comparison. So my view, I want to ask you to shape it and extend it, right? To do that level setting for us. So from my perspective, MBSE is a practice within systems engineering that focuses on the use of models, right? Sort of by definition, that makes sense, rather than documents. And it's to describe systems and systems of systems. So just like systems engineering, but models instead of documents. And I think it uses four main interconnected pillars. And that, to me, this is kind of the key of what's defining it. So that's requirements, structure, behavior, and parameters, right? And so you look at those four pillars for modeling, and you use software tools to build, analyze, and operate those models. And to me, that's what MBSE is about. But David, take it from there. Like, help us understand, is that really a good view?
So Jonathan, you did a great job of defining that. And let me characterize it. I'll extend it a little bit. So the way I like to say is we've always had models that underpin systems engineering, but they've been mental models of how these concepts really interconnect. You mentioned you've got requirements and structure and behavior and parameters. Well, when we were building Apollo or anything in the 60s, 70s, and 80s, there were engineers who were thinking about how those ideas interconnected. But the best way that they could then capture that was in documents. That was the only technology available to them. Well, now we have the power of digital, be it computing power and storage power. So rather than having all that data trapped in a document artifact, we can effectively create these massive knowledge maps, call them databases. We can visualize them any number of ways. We can run computations on them. And so model-based systems engineering is about an approach that gets all that knowledge out in a more actionable way to handle both what I call the descriptive architecture, but then also at a system or systems of systems level, a rudimentary performance architecture. Not high fidelity physics, that's coming elsewhere, but at a first order understanding, how's my system going to perform from day one to day end? So yeah, you had it spot on, Jonathan. Just a few more words to extend it.
No, but I think those words are very helpful, and I appreciate you doing that extension of it, right? To say it's not that we never had models, it's just they were implicit. Now they're explicit in technology. We can use them. And it reminds me of this conversation always comes up in every podcast these days, but it reminds me of something that gets talked about with AI, that AI is about being able to deal with larger data sets. Well, in some ways, what we're talking about with MBSE, so forget I said AI for a minute, but MBSE says, hey, you know what? We can have this large data set within an explicit model instead of strewn across lots of documents. So
correct, and it's driven by a couple things. So its clarity is greater than ambiguity. Explicit is better than implicit. But the other thing, both driving AI and model-based systems engineering, is this increasing complexity curve in what we're trying to build. Well, we think about scale and we think about mission complexity, both of which mean we have to better capture and communicate our concepts. From a systems engineering perspective, we also care about the team that is building these grand systems. They are more complex than ever before. You've got multiple disciplines, you've got multiple organizations. So as you're communicating across that greater breadth, in the same way that you need greater clarity and scope for AI, you need greater clarity and scope for the teams that are engineering these systems. And MBSE helps us there.
That makes perfect sense, right? And so that all that clarity, I think, helps me understand, right? And the history, sort of thrown in there too. Okay, how did we get here? And is it the same thing as systems engineering? Well, yes and no, So anyway, that was all great. I appreciate that. But the topic today, is about how it fits with digital twins. So I want to come back to digital twins for a minute to get into how MBSE and that definition fits within that picture. So, I don't want to get pedantic here and caught up in terms, but we've talked about different kinds of digital twins, and I think that matters a little bit to the conversation here. The terms we've used have been things like a digital surrogate is something that the digital model controls the physical entity, whatever it is. A digital shadow, where it's like the data sort of flows the other direction, meaning the physical entity shares data, probably sensor data, performance data, back with the digital model. And then digital twin being, okay, the information flows both ways. You can send control information, but get performance and response data back from the sensors. And so, there's different modes in which maybe these digital twins operate that are relevant to how MBSE fits in. So having said all that, where do you see that MBSE fits in with these various types or the whole picture? Give us your view of that, please.
Yeah, so the way you lay out those three different types is highly valuable. And if I try to position model-based systems engineering, and for that matter, systems engineering under this, remember that systems engineering is involved, we begin to be involved at the very front end, trying to translate from the customer need and concept into a high-level architecture that enables us to bring our specialty knowledge and engineer these new capabilities. Now, systems engineering remains involved through life, but our primary contribution is driving that architecture with the subject matter experts. Let's now translate to how MBSE then relates to digital twin. The digital twins are going to be these high-fidelity representations, as you said, surrogate, shadow, or full digital twin. Well, that high-fidelity representation emerges later in life.
Right.
The model-based systems engineering is emerging earlier in life. And while we will have a systems model, it will not be of the fidelity to achieve those real-world results that we're looking for. So what does MBSE do? MBSE is a higher-level descriptive model that sets the framework that allows us to build and connect these high fidelity models. It also sets the framework that helps us engineer the manufacturing system and the enterprise that govern these models. In the early days, it could serve as a very low fidelity model, but it's an enabler on the engineering journey as opposed to being something that lives in the operational space where surrogate, shadow, and digital twin really do live through life.
So I want to introduce another term because I think it's germane to the comment you're making there, right? And this is one that is probably not quite as universal. Again, not to get hung up on the terms, but I hear some folks, Dassault in particular, uses this one a lot. They use the term virtual twin. And a lot of times I think what they're talking about is it's the digital representation of something that eventually will get a physical representation. And as you're talking about sort of early stage, it makes me think like, well, maybe MBSE plays a big role in that virtual twin, but as we get into the more full fidelity, it's a diminished role. Is that some of what you're saying there?
I think that's a great way to say it. And again, without being pedantic and without being too precise, a systems level model, an MBSE level model, is going to be a first order type model. And so that virtual twin early in life is a great analogy. And then as you bring more and more fidelity and precision, then it's not that the first order model goes away. It is still the architecture. It is still kind of the tissue that binds together the high fidelity model, but it is in that virtual space. It's not to the surrogate shadow digital twin level where you're now at the full fidelity.
Yeah.
Is there ever a scenario where the high fidelity digital twin model affects or changes the initial model in the MBSE side?
That's a great question, Julianne. And the answer is it should in two ways. One is in the early days of architecting a new capability, we don't necessarily understand all of the interactions, all of the phenomenology. And that's where this idea of emergence comes in, where the whole is greater than the sum of the parts. Well, the high fidelity model can show us phenomenology or effects or sensor data from the field that says, hold on, guys, there's something that we failed to account for in the systems model. So we should have a feedback loop when that occurs. That governs the current system, but it also governs next generation systems. We like to talk as if we build every product new first time and then we just move on. That's not reality at all. All of our organizations are some form of product line organization. So there should be this feedback loop between what's happening in the field, the things that we're learning, and then the capabilities that we add for the next generation system.
So I want to go back to something that we were just talking about and make sure we get clear on a definition for our audience. I think I've got a concept of it, but I want to make sure we talk about it. When you say a first order model, right, I hear that and I hear concepts like 0D, 1D simulation, those kinds of things. Can you just kind of take us through that quickly, David, to make sure everybody's level set on that?
No, you've got it exactly right. It's 0D, it's 1D type modeling, because what's going on in model-based systems engineering is, first off, I said that there's this concept map that interconnects things. So at a descriptive level, an MBSE model helps us connect the problem space where we've got requirements, needs, things that we're trying to accomplish, with the architecture space, the structure and the behavior, the parts and the functionality activities, and then the analytical space, the physics that actually govern the system. Okay, so that's what's going on, but it's at a concept level, requirements to solution, and at a lightweight equation level, 0D, 1D, right, for the analytics. Can you simulate these things? Absolutely, but they are primitive simulations relative to what you would see in computational fluid dynamics or electromagnetic interference. So that's why I refer to it as a first order model. 0D, 1D is a much better term. And then you go high fidelity with anything that think of all your high fidelity tools in the various subject matter areas can deliver.
right? Your FEAs, your CFDs, the things that are going to take high compute power and take a long time and that sort of thing.
Yeah, exactly.
So that actually brings up a really interesting point. And this is probably going down a rabbit hole, so I'll be careful here. But we had a recent episode where we were talking about simulation and how it fits into the digital twin. And it's interesting because it's the counterpoint to what we're saying here, right? So in that discussion, just bringing back a little bit of that, it was, you really aren't going to run full-fledged simulations as part of your digital twin either because they take too long. So I hear there's this interesting middle space, and we talked a little bit about it in that episode, of simulations. You need them, like you just said, to expose things you didn't know, to see details you didn't see, to understand things that go back into your system model, and then maybe make some new observations. But you've got the system model that could be much faster, right? And I don't want to propose exactly how all of that works. I've seen some tool vendors who have those capabilities, but much faster. But then there's this middle ground, right? Which we talked about over there, functional mockups, and the idea that you could take a high order simulation and reduce it, and then maybe plug it into your 0D, 1D and your models to get something in between. So I think it's interesting that we see this MBSE has a play, a simulation has a play, and there's something between where they might connect. Does that sound right to you in terms of the space here?
It absolutely does, Jonathan. And the thoughtful engineering organization is going to figure out what is fit for purpose in each of those spaces and how to bring it to play. Because in the MBSE space, a good model-based systems engineering representation operates as a virtual systems prototype from day one. It's just very, very low fidelity. And so then as we work and apply our systems engineering resources, what are we trying to do? What we're trying to do is to get insight into new capabilities, new ranges of performance, retire new risks, things like that. How can we do that? Well, we can drive that virtual systems prototype, that systems engineering model, down to the next level of fidelity, but we're not driving it down to the atomic level. We can connect it to those functional mockups, the higher level capabilities in specific areas. So you get a jagged granularity, let's say, in precision. But the objective at the systems level early on isn't about being precise. It's about quickly being accurate and getting the team aligned so that then you have that architectural framework within which each team can do their job, bring their magic. And so I love the way that you tied together that low fidelity systems, the high fidelity simulation, and then the ability to package the in-between space. And we as engineers, we as organizations have to figure out, how do we leverage each tool in our toolkit, because we don't have infinite time and infinite computing power at all points.
Right. And it comes back to something that we've talked about several times related to digital twins, and this series we're doing is that every digital twin is unique in terms of what an organization needs, right? And so to your point, I'll give an example of a digital twin in my house, which is the thermostat, right? So I've got this digital thing that's controlling the heating and air conditioning, but there's a model that runs inside of it. Well, it's a low order model, right? I mean, it's doing some basic math with just a few sensors, but it is a true digital twin. It's controlling and sensing what's going on. But it's just a reminder that, that is of the lower order, but still a very valuable digital twin. So it doesn't always have to be, the thing that we conceptualize when we say digital twins. And it's good to know just how these components come together.
Good engineering is always fit for purpose. And one of the things that is most dangerous are all of the demonstrations, all the magazine articles, et cetera, that seduce us with these high capability, high precision. Hey, when we need them, we need them. But engineering is about elegance. It's about doing what you need to do with what you have. And so low order digital twins, we need to do a lot of them. If that fits your need, stop there. And so that's great guidance, Jonathan.
Yeah. I want to go back to something that you mentioned in an answer a few minutes ago, because I don't want to let it go. you mentioned that systems engineering is not just about the product, right? It's also about the organization and the enterprise. And it reminds me of something that I want to dig into, right? So when we think about how MBSE and the digital twin fit together, we could be talking about the digital twin like a digital factory,
Right.
of how we produce it. We could be talking about some sort of twin of the enterprise, the organization of people and projects that come together to deliver the product or the factory or the whatever. So it can encompass a lot. In
Yes.
those cases, there's a term, and I'd love you to just explore this a little bit for us.
Sure.
Enterprise architecture, right? That sort of fits logically with, if we're doing systems engineering of the enterprise, maybe it's an architecture we're interested in. But where does that fit? Is that MBSE? Is that part of this discussion?
Systems engineering can be applied there. Model-based systems engineering can be applied there. So to a systems engineer, everything is a system, okay? The product that we build, the digital factory, the factory that builds it, the enterprise that engineers and supports it, all of those are systems from the right perspective. And therefore, if your product has an architecture, if your factory has an architecture, doesn't your enterprise also have an architecture? Yes, it's called an enterprise architecture. Can it be engineered? Yes, it can be systems engineered. The difference as you're moving across those levels is at a product level, you're talking about electromechanical, cyber, sensors, things like that. When you're engineering at the enterprise level, it still needs, it's still structure, it's still behavior, but your implementation technology is largely human and process and policy. So same fundamental concepts, systems engineering can be applied there, which means MBSE can be applied there. The difference is what's your implementation technology?
Okay, that makes sense. And so, yeah, it makes me wonder, and this is probably the rabbit hole I shouldn't go down, right? About where is that middle ground when you say, okay, MBSE, great fit for making a product, enterprise architecture, great fit for figuring out how an organization is going to behave. And then when you bring that together and you say like, well, so what about factory? Where does that fit? But I'm not going to worry about that for now. I think your point's well made. It's a blend.
I will say one thing though, and it's engineering. It's known as Conway's Law. For those who aren't familiar with it, Conway's Law says loosely, the systems that we build are reflections of the organizations that build them. The organizations that are leading in the field of digital twin and digital engineering are often doing so because they have engineered their factory and their enterprise before they've engineered their product. In other words, their organization is designed so that the product that they produce will yield what they want. And their organization is designed to have, if it's the agility, the quality, whatever, they recognize that those are organizational characteristics that then manifest in the product. So like you said, there's a rabbit hole there, but recognizing that it's all interconnected and that factory, we should probably spend more, as organizations, we should probably spend a little more thought cycle on that than we do.
That was kind of my question. I mean, how often are you seeing or hearing companies take that approach?
It's rare, and it's easier, Julianne, for a new emergent organization to take that or very highly focused. And so who am I talking about? On the one end, it would be a SpaceX. On the other end, it would be Formula One racing. Those guys engineer their enterprise and they engineer their factory because they've got a very focused customer, a very focused mission, and they engineer the capabilities into their factory. In the case of Formula One, so that week to week, they can run all these simulation turns so that they can replace 10% of the vehicle based upon the new track. And that, by the end of the season, I think only 10 to 15% of the car is actually the same as what started. That's a factory capability, but you recognize those are either very, very focused or very new, which means they were able to be, quote, born digital. as opposed to our legacy organizations that have this heritage of operation that's harder to evolve.
Yeah, and I wonder if this whole drive around sustainability will drive some of that need at the factory level as they're trying to push, better practices through their life cycle.
Absolutely. If we don't engineer it in at the enterprise and the factory level, the product is a manifestation of the factory. So computational, sustainable, other societal interests, factory is where it comes to play.
I love that point that you just made, and I think it's an interesting one for our audience. I hope people are sort of focusing in on that. I know I did. That this, the product and the factory are a reflection of the organization, right? That if you're thinking about digital twin and you're thinking about how to have these capabilities in your organization, you may have to step back and say, wait, do I have the culture to support it? Do I have the approach to support it? The organization, the structure, all those things, right? So that's a really interesting insight. Thank you for that.
Well, and Jonathan, let me give you a piece on that, because now I'm going to go back to Mbse for a minute, but I think it translates. Back in 2019, there was a forum that was talking about Mbse, the adoption. How do you successfully deploy in an organization? And the question was raised, what is more important to success in organizational change of Mbse? Is it the leaf level engineer who embraces the technology, or is it the C-suite, the senior executive that provides top cover? And the agreement was you need both. But what we overlook when we try to deploy change, and digital twin is change, is actually middle management. Middle management, in my language, is where change goes to die.
Now, I've heard that before.
That sounds like a very negative statement.
It does.
but it's not meant to be, because middle management, their job is to make the current organization work. And so they're not only empowered, they are responsible for making the organization work the way it does today. And so if we're going to try to deploy digital twin, yes, we need the senior executives on board. Yes, we need the engineers on board, but we also have to bring middle management on the journey so they understand why this is important, how it positively impacts them personally and their function, and the role that they need to play in that transformation.
I love how our podcast episodes, Julianne, all seem to come back to the same themes, right?
Me too,
we just
really.
touched on OCM, right? We've talked about organizational change a lot, and that the point you made is a great one on that topic, David, about how it all fits.
Good.
Right. Well, speaking about how it all fits, is there things with Mbse where digital twin doesn't fit? Sort of let's add a little bit of clarity of where the boxes are, if there are some.
Sure. The biggest trap in model-based systems engineering is honestly giving an engineering tool to an engineer. And
I identify with that. Wait a minute.
I joke that no engineer ever came in on Monday morning, opens Microsoft Word and goes, it's going to be a great week. But
I don't think anybody does.
Yeah, let us loose with our engineering tools. And what'll happen is we'll go too far, too deep. At an Mbse level, we need to recognize where our role is. And that is to set the governing architecture to a level of fidelity that enables the various subject matter experts, okay? And there's engineering judgment on where to stop. Okay, how does that play into the digital twin? Well, I said that, now, Jonathan, I'm going to go back to your language, that the model-based systems engineering representation from day one can be a virtual twin. It can be a virtual systems prototype. The trap is trying to drive it to a high fidelity. Just because you can, and as the tools get better, and as the capabilities get better, you can do a lot more. But should you use a Swiss Army knife for every job? No, it's useful to carry. It's very important to have the architecture, but it does not become a replacement for the high fidelity capabilities.
Yeah, that makes sense. And I can imagine an example, right? Having been someone who's used enterprise architecture and Mbse tools, I get that you could take an Mbse tool and you could define so many parameters for a component in a system that you've fully designed it in the Mbse tool, but that probably wasn't smart. that probably wasn't the right idea.
Exactly right. It's a combination of inefficient, ineffective, and honestly outside your lane.
Right.
There are other people who it's their responsibility. They have the expertise and they actually have the better capability.
Interesting. It sounds like it's not a specific, like, hey, here's where MBSE doesn't fit, but a good general rule to think about, right? Remember, it fits in architecture, it fits in tying things together, but don't think about it as plugging any specific hole or gap in the design and definition.
That's correct. And I think one of the things that will help us as we remember that is systems engineering was never meant to be its own silo, which means it was never designed to produce its own product in the way that we think of others. Systems engineering is meant to be that transdisciplinary technical connective tissue. How does that manifest? It manifests itself in architecture. How is architecture represented these days? In one of these knowledge models, in a modern tool, but it stays at the architecture level. The moment you feel yourself pushing beyond architectural bounds, that's your signal that says, I've gone too far. Now let me cross over to another tool, to another discipline.
Yeah, it does. You can see where people could go down that slippery slope pretty quickly, but then, they might, find themselves getting stuck so that the model all of a sudden is not practical.
Well said, Julianne. Yep.
Yeah. Well, this has been a great conversation, but I hate to say that we're coming up on some time constraints.
Fair enough. You could see the look on my face like, oh, I can ask more. And you're like, wait a minute. If I don't stop him.
Really win. Great. So can we move forward with a summary? You got some thoughts on this, Jonathan?
Yeah, absolutely.
David?
It's a little bit tough for me to summarize everything because you've had a lot of great points that you've made, David, in answering these questions and kind of highlighting some things that even we weren't thinking about coming into this. But here's what I took away. So first, we talked about MBSE and what it is, and you restated it in a way that I really liked, as in the nature of the conversation, about needs and requirements, definition, and then analysis, right? I named 4 pillars, but you kind of put those into categories that make sense. That, okay, yeah, we're creating models in those areas. That's what MBSE is. So that I thought was very helpful. We got on to talking about where it fits with digital twin, and a key topic there was performance versus fidelity, right? And where it fits. And the fact that it fits in the virtual twin up front a lot better, a lot more, maybe, I shouldn't say better, but it's a lot more coverage there in those early stages than necessarily MBSE is in the later stages where we need higher fidelity, more control, that kind of thing. Another thing that you brought up that I thought was really interesting, I'd never heard of before, is Conway's Law, right? And that's how this relates to people who are trying to implement it. So we weren't necessarily getting into that today, but I think it's really important, the point you noted about if you're trying to make a digital twin of your product, you need to think about, well, wait, are those capabilities and even that mindset and that thinking baked into how my organization runs and how we behave? So there's a connection between, systems of organizations, people, and enterprises and the systems that we talk about as our products. And we can't ignore that, particularly if we're trying to put these in place. So that there's some more there. I won't get into that because I'll summarize for another 10 minutes. But I think you said something else important when we think about implementation is that you can't get to these kinds of things without everyone in the organization. That was an important takeaway I had from that point that you're bringing up. So the last thing I heard that I thought was really worth mentioning is that systems engineering and then this piece we're talking about, how it fits, isn't its own silo, right? So we are going around in this conversation talking about how X and Y fit into the digital twin. But your point is, look, MBSE is not that. It's the umbrella. It's the connective tissue. It's not its own domain. So that to me is another important takeaway for people to think about when they think about how it fits. So I heard a lot more than that, but those are the key ones I took away. What did I miss, David, that you're thinking, let's make sure the audience heard this too?
The only thing that you missed, and you did a great job, Jonathan, summarizing it,
Thank you.
is I'll add a little flavor on how MBSE should be thought of in this space. And you use the term umbrella. It's a good term, but I'm always very careful to draw it more at a foundational level or at a middle level. And the reason I do that is oftentimes Systems engineering can be somehow presented as above other things.
Okay.
It is not above other things. It is absolutely an enablement function that brings the other expertise together. It's not better. It's not worse. I will often say that good systems engineering in isolation is completely worthless. And so I'm always very careful as we talk about the role of systems engineering in MBSE. Let's make sure that we talk about it. Yes, it's in the conceptual phase early, but it's not above. It's on par with everything else, helping to connect all this expertise that we have to greater organizational outcomes.
I appreciate you underscoring that, right? It is, like you said, the term you used was connective tissue, right? In the middle of everything, not above, not below, but like really it's the glue holding it all together. So yeah, thanks for emphasizing that.
No, but great summary.
Yeah. And I don't really have anything to add on all that. I think that was excellent. I think the takeaway for me was just that point you just made, that it's part of because I had a sort of a perception that it was sort of a driver of a lot of things. And it probably does at some level drive some things, but what it really does is bring together expertise for people to do what they do best. So I really like that thought around that. Okay. Wow. This has been one heck of a conversation. So we really appreciate it, David.
Absolutely. It's been great. Thank you for being here.
Thank you so much for being here. And of course, we'd love to leave the door open for you to come back for another chat with us if you could.
I look forward to it.
Because I've got more questions, that's for sure.
And I got more answers.
Awesome.
This is a perfect combination right here. Oh, that's great. Well, everybody, thanks so much for joining us today. And if anyone has any questions for David or anything you want to ask about MBSE, David is certainly one of our resident experts here that's been on the podcast. So we'd be happy to channel any questions you have for him and get you some responses. But as always, we appreciate you being here today and listening in. And and we hope you'll be tuning into some of our future episodes. And until next time, everybody, stay sharp.
Thanks, everybody.
Thanks for being here and listening to this episode of Stay Sharp with Razor Leaf. If you like this podcast, please be sure to hit the like button and subscribe to our podcast on your favorite podcast platform or watch us on YouTube. If you have any questions, just leave us a comment on our post or send us an email at podcast@razorleaf.com. We'd love to hear from you. Until next time, everybody, stay sharp.